Titrations are performed as a common laboratory method to primarily determine four things: the solubility of products, the stoichiometry of reactions, the number of electrons gained or lost in a redox reaction, or the concentration of an identified analyte in a solution. In this particular exercise of the Titration Lab, we determine the concentration of citric acid in Sprite. To accurately do this, we had to know the concentration of the titrant. As a titrant, we used a standardized solution of sodium hydroxide with a predetermined molarity of about 0.0089 moles per liter. Throughout the lab, we collected data, including the volumes of both the sodium hydroxide solution and the soda used. By taking two readings of volume, we could subtract initial quantities from final measurements to determine the amounts of each solution delivered. When using the pipette and burette, volumes were read to the hundredths place because both glass instruments have graduations to the tenths place. These volumes, along with the concentration of sodium hydroxide, were then plugged into the equation: molarity of sodium hydroxide times volume of sodium hydroxide solution in liters divided by 3 equals the volume of soda times the molarity of citric acid. We divided by 3 on the sodium hydroxide side of the equation because the stoichiometric ratio of sodium hydroxide to citric acid in the reaction is 3:1. Before each use, the burette was primed by rinsing it 3 times each in water and solution. For the first trial, I performed the titration. My initial reading of NaOH solution, the basic titrant, was 1.59 milliliters. I then delivered some solution to the reaction vessel, which contained 4.98 milliliters of acidic soda and 3 drops of our indicator, phenolphthalein. I swirled the reaction vessel to properly mix the acid and base. After the solution turned light pink, indicating the endpoint of the reaction, the final reading on the burette was 11.15 milliliters, so the amount of sodium hydroxide solution I delivered was 9.56 milliliters. Doretha then repeated the process. Her initial titrant volume was 2.72 milliliters. Her final volume was 10.45 milliliters. Therefore, she delivered 7.73 milliliters of basic solution to the reaction vessel, which initially contained 3.60 milliliters of soda. Michelle went third. She began with a measurement of 10.79 milliliters. Once the reaction was complete, she read 16.01 milliliters from the burette, so she had delivered 5.22 milliliters of sodium hydroxide solution to 2.85 milliliters of soda. In Catherine Thompson's trial, she took an initial reading of 16.00 milliliters of NaOH solution. She delivered the titrant to the reaction vessel, which contained 0.61 milliliters of soda. Once she reached the endpoint of the reaction, her final reading was 19.41 milliliters, so she delivered a volume of 3.41 milliliters of titrant. In her final trial, Sydney began with a reading of 19.42 milliliters of titrant. She delivered the basic solution to the reaction vessel until the 3.71 milliliters of soda and phenolphthalein turned light pink. Her final volumetric reading was 23.71 milliliters, so she delivered 4.29 milliliters of NaOH solution. We recorded all our data in our notebooks for use in calculating the molarity of citric acid in Sprite.